Okay, so people are joining. We will start class in 5 minutes, okay? So I will wait for people to join, and class will start at 6:05. Dhana, please mute yourself.
Yep. And
Yeah. We will start in few minutes, okay? Nitish, okay. I think we can begin now. Okay. Let me share my screen and then we can start. Okay. Um, so good evening everyone, and welcome to third session of this live interaction class for Matlab based programming lab in chemical engineering. Okay. So I am the current TA for this live interaction session. My name is Bhavesh Moorjani. Little bit about me. So I have done my bachelor's from MS University Baroda, and then I completed. Worked at Gujarat State Fertilizer for 1.5 years, and then I joined as a PhD student at IIT Bombay. So during my graduation, I was introduced to MATLAB programming, and in my research work also I use MATLAB to do some analysis part. Okay, so for this coursework I'm trying to help you guys to get used to features of MATLAB program in the MATLAB and solve various problems. So these are the various ways you can contact me if you want help regarding this course or any other query. If you have, I will try to reply to you as fast as I can. Okay, so before beginning to the today's lecture, so I want to recall the last two lectures. So what we did in the last two sessions. So first session was about understanding what is the role of modeling and simulation as a chemical engineer, and why we should rely on numerical methods or any such programming language, right? And then we learned about basics of Matlab, what Matlab is, what kind of uh, basic operations we can do in Matlab. And the last lecture was focused on creating your own functions, then doing looping in Matlab. So we learned some programming aspect where we solved some problems through for loop, while loop, if else condition statement we learned, right? Now from this lecture onwards we will focus on some of the chemical engineering problems aspect. But here, before starting today's lecture, I also want opinion from you guys that the how exactly you want to proceed from this lectures onwards, right? So what sir has taught in the week third week's class is about solving the friction loss in pipe. So he started with this problem. Okay, so you have given a scenario where sulfuric acid is flowing through a pipe with a given dimensions, and then you have to determine what is the head loss in this pipe due to the friction. And then further to this problem was to examine how the friction head loss changes with the Reynolds number and generate your own Moody chart, right? And to solve that, so what we learned was, so you have to find the friction factor, you have to to find the head loss for a flow through pipe, you need to find a friction factor, and then that friction factor we can find from Moody charts or through the empirical equation that we have. And that empirical equation is like this for a smooth pipe and for a rough pipe, right? And we learned in the class to use a inbuilt solver from a Matlab to find the friction factor for a given Reynolds number, which was done in the class. And then so we solved this equation, so this non-linear equation through F solver to find the friction factor, and based on the laminar or turbulent region we find the friction factor and put that into our Darcy-Weisbach equation or Hagen-Poiseuille equation to find the head loss in the pipe, right? And then sir had, I think, spent 2 class to build up the code. So this build up the code in the Matlab, and then last part was about doing plotting part. Okay, so now since this problem is very straightforward and sir has spent enough time into this problem, just a minute, what is happening? Yeah, and sir has spent enough time into that problem, so I'm not sure whether to reiterate this problem or start with something new. And repeating same problem also won't help you guys too much. So what I'm thinking is to take key points from this week's problem. So in this week's problem, mainly thing that you learned was to use the solver, inbuilt Matlab solver, to find the solution to your nonlinear equations, right? So I'm focusing on that, and then we will learn what are other solvers we have that we can use to find the solution to this nonlinear equation, and that you can utilize in your any chemical engineering problems where you encounter such equations, right? So I want to follow it that way, and then we will try to solve some of the related equations what sir has taught, right? So is this approach correct, or do you guys want me to repeat what sir has taught in the class in the greater detail and then do some extra problems based on that? I think there is only 2 people are there right now, so if you guys want to share your opinion that how should I proceed, you can share it with me. Is it okay that I follow my method, that I take some gist from what sir has taught in the class and then build questions on that, or you want me to repeat what sir has taught in a greater detail and then do some problems based on that, or problem or which are similar to what sir has done it? Can I get any answer? Don't worry about it. This is just I'm asking for an opinion. And if any one of you who will watch in at YouTube, you can also comment on the YouTube video itself that how you would like me to proceed. Okay. Since I assume that the sir has explained the problem in a greater detail, so we don't have to spend much time repeating that. So I'm following a new method. Okay. So with that, let's begin this class. If you find that I should spend some time, then do let me know. Okay. So while when we are solving this chemical engineering problems, we will often encounter such non-linear equations that we have to solve in order to get our solution, right? And we are talking about non-linear equations. So we have two types of non-linear equations that will come into in our problem. One could be the algebraic problem, and one can be transcendental problem, right? So what are the algebraic equations? So algebraic equations are nothing but equations that can be represented in terms of algebraic operation, which is addition, subtraction, division or multiplication or raised to the power functions, right? So like our quadratic equation, that is nothing but the algebraic equations, polynomial equations, that are all the algebraic equations, and for them we can find their solution analytically also, that is possible. But transcendental equations are equations which are not algebraic in nature, and they involve a transcendental function. Okay, so what is this transcendental function? So this transcendental function is a function which does not satisfy the polynomial equation. So you cannot represent this function in terms of polynomial or any coefficient. So basically you cannot simply represent that function with the combination of some variables, addition, subtraction. So your exponent, e to the logarithmic equations, or equations that involves this trigonometric function cos sine, they are nothing but your transcendental function. And the equations which contain this transcendental functions, they are called as transcendental equations. Now they might have finite or infinite root, right? So what do I mean by root? So root will be, if this is the function fx, which will be x minus e to the power minus x. So if fx is equal to 0 for whatever x value, that will be its root, right? So when we are dealing with the algebraic equations, it might be possible to solve them analytically, right? So for a quadratic equation, we know that we can find the root as minus b plus or minus under root d square by 2a, right? So that thing is possible. But if you have such sort of equations, then analytical solution is not very easy to do. In that case, you have to rely on the numerical methods to solve a problem, right? So when we have this transcendental function, in that cases we should rely on the numerical equations or numerical functions. So solution to such equations can be done from a numerical method. So for that we have various numerical methods. I am starting with the basic numerical methods that you would have learned in some of the maths course. One is this bisection method, where you start with you start with an interval. So you have two bounds for bound value of a variable, and then you narrow down your search by halving the intervals, right? We will discuss this in detail. Then there is a golden section method, secant method. So these three are non-derivative based methods, so you only have to find the function value. Then the Newton-Raphson method, there it's a quadratic conversion, so you rely on the derivative of function, and then based on that you come to the solution of a problem. Okay, so if you want, you can use such numerical methods to find your solution, or rather if you have such software like Matlab, then you can rely on the Matlab and use its pre-built inbuilt packages like f0, fsolve, solve roots. So these are the various commands which help you to find the solution of to this nonlinear equation, right? So this is the stuff. So what we will try to do is we will try to understand these numerical methods So we will consider this bisection method and the Newton-Raphson method, how this method works, how if we want to code this method, how we can do in Matlab, and then we will compare this with a inbuilt solvers that we have in a Matlab, right? So for that, let's first look at what are this inbuilt solvers we have in the Matlab. So right now I'm discussing this 4 part. One is F0, Fsolve, VPA solve and solve. Okay. So we will look at this problems with these functions with an example. Okay. So let me have one live script and sorry. So first function is F0. So F0 is used to find the root of a scalar non-linear equation for a single variable, right? It requires you to have an initial guess or interval where the function changes sign, and it uses the combination of bisection, secant and quadratic interpolation. So the method it uses to solve this non-linear equation are combination of this method, right? So first let's try to see what exactly we mean when we say we to use an F0 function, right? So in the Matlab, if you will first search help F0, so it gives you the basic idea about what this F0 command does. So F0 is a single variable non-linear zero finding. So you will have a one variable function and it will find the roots for that function. So this is the syntax. So for F0 function you will need two values. One is the function itself and x0, which is an initial guess for your function, right? And this, mind you, this is a single variable function. So here are some of the examples. So as you can see, this is F0 where your function is sine and initial value starts with the 3. So sine close to the 3, it will find what will be the value which will correspond to 0 value of sine, right? And then you will get an answer. Similarly, you can put your own function. So here they have created my function which is a cos of c time x, and then you find what will be the 0 value of this function. If I look into the detailed documentation of F0 command, here you will find further more example for this command, right? So you can use your functions. So I can provide this, so they have provided this cubical equation x cube minus 2x raised to 5, and then if we want to find the solution of such functions, that also can be done. So let's look at some of the examples through examples here. So here, no, this one I want F0. So let's consider any function. So to define a function, I am using f at the rate. We learned this in the last class, right? I can start with any function as this. So it's a function of x. Okay. Let's consider the example here. It's a very basic example that my function is x square minus 4. Okay. So this is my function. Now my initial guess, let me provide an initial guess of 1 because I don't know right now. This is my initial guess. Then my solution can be, I can write f0, then my function f and initial value x0, right? And if I try to run this, I will get this answer, right? So my function is created, which is x square minus 4, and solution to that function. So for x equal to 2, I will get fx is equal to 0, right? So this is one example. Let's consider another case. So if here, let's consider this exponent of minus x to x. So now my function, I change it to x exponent of minus x, right? Yeah. So this is my function. I provide some initial guess value and then I solve it using f0, f comma x0, and then you run it. So here it's giving me the value of 0.5671. Now I can check this also, that whether this value gives me exact 0 or not. So you can see my answer is 10 to the power minus 16, which we can assume is 0. Okay, so it's 10 to the power minus 16 value is close to the 0. Okay, right? So this is how it solves. Now when you are using f0 command, your initial guess becomes an important aspect, right? So let me try to visualize this plot, visualize this equation. So last class we learned about this EZ plot, right? So in the EZ plot, if I provide an equation with an interval, let's say minus 10 to 10, first I want to see how exactly this plot will look like. It's creating the plot. So this is how your EZ plot looks like, and here you can see at one point only it's touching the value of 0, and then again it's going in the other way. So if I lower my interval, let's say minus 2 to 5, and run it. So here I have only one point where the function will be 0. Okay, now my initial guess was 2, so it gave me the solution correctly. But sometimes what could have happened, that if your initial guess is not correct, so let's say I would give initial guess of 100 and try to see whether this converges or not. Still it's converging. So the method it's currently using, I assume it's probably the quadratic method, so it's converging it much faster. But sometimes when we will come to the bisection method, you will realize that your initial guess becomes an important part in finding the solution. So if my initial guess is not correct, or if it's far away from my minima, then it's possible that my method might not converge. Here the equation is much simpler, so that's why it has converged much faster, and you can see it only has one minima. Let's say if equation has multiple local minima, in such cases also your equation might converge at local minima, so you have to be careful about that. We will come to such example, some of these examples where we have more than one minima, but as of now just take this note in the mind that when you are using such solvers, your initial guess is also an important aspect that you have to look for. So we learned about f0 command, which uses equation and the initial guess to find the numerical value where fx is equal to 0, and it's a single variable function. Then you have fsolve, which solves system of nonlinear equations. So you could have multiple equation as well as multiple variables. Here also you will require an initial guess method, and the solution to this equation is done by trust region, reflective, or Levenberg-Marquardt method. Now you don't have to worry about this algorithm. This is just to give you a basic idea. If you will do some of the optimization course, there you will learn about such methods. So for univariant optimization, you have this bisection, golden rule method, secant method, or the quadratic method, which are the Newton-Raphson methods, right? While for a multivariate optimization problem, you use this stress region method or Marquardt method, right? So that is, you don't have to worry about, but it's good to have a basic idea what this solver or what this command is doing in the background part. Now let's check out the fsolve command. So for the fsolve command, this is how this command works. So fsolve solves the system of nonlinear equation of several variables. So here also you will need a function value along with the initial guess. So there are some example given, right? So this is the basic example. Like here, so you have system of two equations, 2x1 minus x2 exponent of c to the power exponent to the power cx1, and this is your second equation. And then you put it into fsolve as a function with an initial guess. The constant value is determined, and then you get the answer. If you want a detailed explanation, you can again check into documentation part, and it will provide you various examples. So here you can see, so if you have such multiple equations, then you can take the help of fsolve, and this was done in the class also. So in the class where we had to solve the equation to find the friction factor F, right? So calculation of the friction factor was done using fsolve command. I think it was here. Yeah, here, right? So this was the command. So you have so this is your function, okay, and then you put it into fsolve with some initial guess value, so it will give back you the friction factor value, right? So this was the empirical equation that we solved using fsolve command, because it's a non-linear equation and you cannot directly solve it. So similarly, when you encounter such bigger non-linear equations, in that case we will take the help of fsolve command. So again, let's look at some of the examples. So here first example looks at the two values, right? So let me put it here. F right now I'm commenting the above part. So let's say we have two equations in our system. So here you can see we have created this two equation. One is x1 square plus x2 square minus 1, and second equation is x1 minus x2. Okay, you can provide the initial guess for x1 and x2, which is this here. So the initial guess provided is in terms of vector, since we have two variable here. First is the x1, okay, and then second is the x2, right? So when you find the solution is equal to f zeros, your function func, and then the initial guess that you have, right? And if you run it, so here you can clearly see there is some error. Oh sorry, I want to use fsolve. Yeah. So equation has solved and it has found its value, and this value has also been printed, right? So so you can see my equation is x1 square plus x2 square minus 1, and second equation is x1 minus x2. So if you want both of them to be 0, you can find it like it's 0.707, so which is 1 upon under root 2, right? So 1 upon under root 2 square plus 1 upon under root 2 square, that will be 1, 1 minus 1 0, and here it becomes 0. So this way also you can solve the multivariable multi-equation problems with the help of fsolve command. Okay, you can also yeah, this is the same example, I guess. Initial guess and final. Then on the next command line option you have this VPA solve command. So what does this command does is it finds the numerical solution to symbolic equation. Either it could be single variable, it could be multivariable. You don't have to provide an initial guess, but you can use some boundaries to define. If you want, you can provide some boundary, right? It works with the symbolic variables and can find the solution in a specified range, right? So let's understand what this command does. So this is VPA solve. So if I look for VPA solve, so this is the documentation part. So VPA solve finds the numerical solution of an algebraic equation. Okay, here you can solve the system of equation. So you can have multiple equations with a multiple variables, and then we can find the solution. It does not require initial guess value, but if you want, you can provide the starting value as a x0. So let's look at some examples. So here what you have to do, so in this case previously what we used to do was we would define, like in the fsolve command or f0 command, I will create an function which will represent my equations, but here I can create an symbolic equations and I can put that equation inside VPA solve. So here you can see you have to first define some symbols. These symbols, when you define the sims x, y, z, so this will become a it won't become a variable, it will become a symbols which you can use to call or write any equations. So based on the symbols, different equations are wrote, and then when you use this VPA solve command, it will find the numerical solution of this equation. So if I define, let's define some equation. So this is SYMS, let's say x and y. I define two variables, SYMS. So I define two symbols x and y. What happened? Just a minute. No, there should be no comma. X and y. Okay. So you can see here x is appearing as symbol, variable y is also appearing as a symbol. Okay, so value, it's x and y. So these are the symbol, right? Compared to that where you have other variables, it's writing it as SYM. Now you can define your equation. So let's consider one equation from the top part only, where I use this equation x minus 2y cube plus 1. So this is my equation. So I define equation is equal to x minus 2y cube plus 1, right? Oh, sorry, yeah. So this becomes my equation. Here again equation is also defined so in form of a symbol. So compared to this, yeah. So this is a functional handle. So previously for the fsolve command and f0 command we defined the functions, but right now we are defining the symbolic equations, and these equations will be used to solve the to find the solutions, right? So now you can use VPA solve and then your equation, okay, and it's giving me the value. Okay, so it's providing me the numerical value for the solution of this equation, right? So if I put x is equal to -1, -1 cube is -1, y's value is 0, So 1 minus 1, I get the 0 answer, right? Here I didn't have to provide initial guess. Here I don't have to provide any such initial part or even the interval, right? Still it gave me the solution, and my equation was in terms of the symbols only, no numericals value were provided. So this is the beauty of VPA solve command. There are some other examples also. So let's say I want to solve the equations like this. So now I am defining symbol x. My equation is this. So here in the previous part we just defined the equation as x minus 2y cube plus 1. It didn't had any LHS or RHS part, right? So in that case, when we use VPA solve command, it will consider this function is equal to 0, okay, is equal to 0. It will consider it that sense. But let's say you have function, you can also provide it the equation in terms of this value. So here I hope it's clearly visible that you can write equation as x cube minus 6x square plus 11x minus 6. I am also providing that this equation is equal to 0. So this is my overall equations, right? So when I do that and call the VPA solve command to find the solution, still it will give me the answer, right? So here I have three possible answers. So if I use x equal to 1, then also you will get the value of 0. If you use x is equal to 2, then also you will get the value of 0, and for x equal to 3 also you will get the values of 0, right? So it has provided me three different answers all together in the symbol form, okay? Then another command that you can use is solve command. So solve command, similar to VPA solve, it is used to find the solution to a symbolic equations, but rather than finding a numerical solution, it will find the exact symbolic solution of an equation. And you can use polynomial, transcendental equations, etc. here. So if you will search help just solve command. So this is the complete detail. So solve command is an equation in system solver. So if you provide the equation and various variable name, it will give you the solution in terms of variables. Let's look at the documentation part for this. So here, let's say this is your equation. You have equation with three different so this is equation, this is our quadratic equation, right? And we know the solution of the quadratic equation. But here I'm not providing, I'm saying that I want the solution of this equation, but not in terms of the numerical values, but rather in terms of my symbolic equation, or rather the analytical solution. So in such cases, the solve command is useful. So let's consider this example only, that I am providing symbols A, B, C and X, okay? And then I am writing my equation as A into x to the power x square plus b into x plus c is equal to 0, right? So this is our equation is, right, ax square plus bx plus c is equal to 0. Now I can use solve command and put my equation and solve it. So it has given me the solution, but now this time the solution is in terms of equation. So it's a symbolic solution rather than the numerical solution. Here if I use VS, the previous command, the VPA solve command, right? VPA solve. So it will give me numerical solution. And how it has given me this numerical solution? All the coefficient, if all the coefficients are 0, then only my equation or my right hand side, like my LHS is equal to LHS will become the RHS. Okay, in that case you can use any value of x. But let's say if I provide the now value of a, b and c is equal to 5, I am providing the some random value. Okay, so ab has changed to a specific value. And now if I call my equation, now if I might define my equation this way and solve it, now I will get the exact numerical solution. Okay, so previously when I did not had defined the what are the ABC, and I asked VPA solve to do and find a numerical solution, it gave me all the coefficients 0. If all the coefficients are 0, then obviously equation will become 0. But when I define the equations, define the coefficients value and asked and I asked VPA solve to find the solution, it gave me a proper numerical solution. Now in this case, when I have coefficients defined, my equations defined based on that coefficient, and let's see what happens when I use the solve command. So if I use the solve command, still it's giving me the symbolic equations, right? So it has not put any value of x, but it's giving me the symbolic equations. So it's saying, so if you will substitute here, so this is -1, right? -1 minus of this I part. So this is nothing but under root 6 into 1. So both are useful to solving the same problem, but one gives you the exact numerical value while other gives you the symbolic value. You might use it based on your specific requirement, depending upon where you encounter such problems, right? So that specific case will come, if such example comes, then we will see it. Else this is just to have a good information that you can use such commands also to find the solution. Similarly, there is one more command which is used to find the solution of polynomials. So that command is root command, right? So what this command will do, it finds the root of polynomial expressions, right? So you just have to provide the coefficient of your polynomial. So let's say your polynomial is like this. So either you can put it in terms of the symbol, so system x, so you define the symbol x, then you write root your equation or your polynomial, and ask it to find the value of where this polynomial will equal to 0. It will provide you that value. I think you can directly use coefficients also. Just give me a minute. Root of polynomial expression. So f can be your symbolic equation where x is variable, k is the integer between 1 to the degree f. Okay. Yeah. I think you can use this part only. f0, f solve and roots. So actually there are two commands. One is root command and one is roots command. So in the root command, like we saw earlier, you have to provide your polynomial equation and then it will give you the solution. But if you already know the polynomial expression, you know the coefficient of that polynomial. So it's a single variant polynomial, right? So if you know all the coefficients, then you can use the roots command to provide the coefficient value and it will give you the answer. So let's say I have this quadratic equation again, and I know all the coefficients value. So to find the solution of this quadratic equation, I only need to know the coefficient, right? And if I know the coefficient here, then if I put it into the root command, I provide the coefficient as a vector and I use the root command. So I have provided 3 coefficients, so it's a quadratic equation. If I provide the 4 coefficients, then it will become cubical equation. If I provide the 5 coefficient, like in this case 1 2 3 4 5, that means I have x to the power 4th equation, and it will find the roots accordingly, right? So if you want to find the solution of polynomials, you can use either roots command, where you have to provide the value of only coefficient, or you can use the root command, where you provide the equation of your polynomial and then it will find the solution, right? So these are the in-between Matlab solvers that you will use depending upon your problems, which eases your calculation, right? So in the class also, when we solve the friction factor equations using fsolve command, if we want to do it numerically, it will require much more longer time, right? So in such cases, obviously we have to rely on the Matlab inbuilt programs. But how does this program works in the background? We want to understand that. For that, what we will do, we will consider 2 basic methods, which I said earlier also. We will look at the bisection method and the Newton-Raphson method, which are univariant optimization method to find the solution of a problem. Okay, so and we will try to code that also, and then we will compare our result with this methods to the what result we are getting from the solver, right? So first method is a bisection method, or it is also referred as interval halving method, right? So interval halving because you reduce the interval by half at every time instance, right? So it's used to find a root of equation in a given specific interval where your function equals 0. It's very basic, simple method. It's effective also for a simpler function. So that's why it's starting level optimization method when you want to find where your function will become to 0, right? So particularly useful when you are using transcendental equations. Okay, now so to find this function, you will need two intervals a and b, in between which your function is continuous, and this function value at a and b should have an opposite sign. What does we mean by that? So let's say this is f(a1) and b1, right? So function value here is positive, function value here is negative. So without knowing how the function looks in between, right now we know that here this is the function graph, right? But let's say if I don't know how the polynomial looks like, so I have one value fa. At a I am getting the positive value of function, and at b I am getting the negative value, right? So this top part is positive, bottom part is negative. Now, so the basic understanding of us says that if I join two lines, one is positive side, if I join two point, one which is on the positive y-axis and another which is in the negative y-axis, it will cut x-axis at some point, right? And at this point my function at this point my function will become 0, right? So this is the basic understanding of bisection method, that you start with the two interval points, one which gives you the positive value, one which gives you the negative value. So that means that in between these two values there will be some value of x for which your function will become 0, right? So what does bisection method does is that once you have this two extreme point, you find the intermediate point by halving the interval. So your next point will be a1 plus b1 by 2. You find the function value at this particular point. Let's say this new value is also negative, you are coming at here, so that means now your minima where your function will become 0 will lie into this part only, right? Okay, so then you further halve this interval and you find the third value. You calculate the function value here, you are finding this value is positive, so now your search region becomes much narrower, that my fx is equal to 0 will lie in between here, right? So similarly you reduce your intervals by halving them till a point where you converge. So what will be your stopping criteria? So your stopping criteria will be where your function becomes 0 or the tolerance or the change in the value of your x value is very negligible, right? So in that case you can stop your iteration. So let us consider one basic example here first. Just give me a minute. So this is the example that I want to find the root of equation, which is x to the power 4 minus x minus 10 using the bisection method. Now so first step of the bisection method is to find an interval in between where we know that function value will become 0, right? So that is the first step. So for that first step, what are we going to do? Let's consider I start with a random guess that f of x function value at x equal to 1. I put x equal to 1 here, I'm getting minus 10, so it's a negative value. Then I consider f of 2 function value at x equal to 2, I'm getting a positive value. So between 1 and 2, 1 has a negative value of x, 2 has a positive value of x. That means in between this 1 and 2 there will be some point where my function f of x will become 0, right? So that's why I say that root must exist between 1 and 2. So this becomes my first interval. Now I have to find that specific point. So for that what we do, we start doing interval halving, we find the next in between point. So first point, so let's consider this is a and b. So my first iteration will give me a plus b by 2, so that becomes 1.5. I find the value of function at this point at x1. So again it's negative. So first it was this, right? First at 1, this is at x is equal to 2, my function value was minus 10. Okay, here my function value is 4, right? This is my point, this is my point, right? Now I find at 1.5, which is here, my function value is still negative, right? And it is minus, pardon my writing here, I don't have a touch pen right now. Yeah, right? So it's 6.4. So that means initially I thought function value is in between, like there will be one point where in between 1 and 2 where I will get the 0. Now at 1.5 I know function is still negative, that means now in between these 2 points there will be some value where my function is 0. So my next interval becomes 1.5 and 2, right? So then my root exists between x1 and 2. So in the second iteration I will use this and further find the in between point here, which is 1.75, and for 1.75 I still find that value is negative. So that means my third point is in between 1.75 and 2, right? So further root becomes between x2 and 2. So again I do half the interval. So I take a bisection between x2 and 2, find the next point, find the value of function. See, now it has become positive, so that means previous value of x2 was negative, x3 becomes positive, so my function will be between x2 and x3, right? So then root becomes between x2 and x3. So similarly you find the new value by finding the bisector of x at between two limits. You check its value and then you determine what will be the next interval for your search. And when you do this multiple iteration, after 8 iteration, what you will find that your function value is coming to 10 to the power minus 3, which is for my application, let's say I consider this is close to 0 and I stop the iteration, right? So my x value for which I should get x raised to 4 minus x minus 10 is equal to 0 is nothing but 1.855, right? Now what will be the stopping criteria here? So I have done 8 iterations. When you do 8 such iterations, you will come to this conclusion. But when we are coding, or I just decided based on myself, but when we are coding or using programs, we have to provide some stopping criteria, right? So that stopping criteria can be based on some tolerance or some absolute average of an error, right? So either I can provide that absolute value of function is less than the tolerance, and that tolerance can be 10 to the power minus 4, 10 to the power minus 5. So let's say I am defining tolerance as 10 to the power minus 2, right? So in this case my tolerance is 10 to the power minus 2. Okay, so this value is less than that, so I stop the conversion. I decide, okay, I have reached the desired tolerance, so that means as x is equal to 8 is a solution for me. Or I can use this difference of two consecutive values, x value at 8 iteration minus x value at 7 iteration. If that is below the tolerance, I stop the value, right? So higher your tolerance, more iteration you will need. Lower your tolerance, that means more approximation you are doing. So based on your applications, you have to decide what kind of tolerance you want. So this was the basic idea of bisection method. But now what we will do, we will code this bisection method through Matlab programming, and then we will compare our result from bisection method to the inbuilt solvers that we have. Okay. So for that, let's go into Matlab and first create a function, create a scripting. So let me have one more. I think this is also fine. I should not. No. This is just to have hand. So I start my script by clearing all the previous variable, clearing the window, and then first thing is, if I am solving a bisection method, what initial information I will need? Can you answer it? Do we have attendance or yes? There are 5 people, right? So what basic information we will need when I want to solve the problems through bisection method? First is obviously I need a function. What function to solve? Okay. So for that, what we will do? We will ask a user to define a function. What is the function that they want to solve for? And then second will be intervals, right? So similarly, if you saw in the fsolve command, right, you provide the function and then you provide the initial guess. So same way, in the bisection method, we will ask user to first provide a function to input the function, and then we will ask them to provide an initial guess. Based on that, we will do the calculation. So for that, I will use the input command. So first, asking users for the inputs. Okay. So first, I ask them to provide a function. Okay. Provide a function for which solution is needed. Okay. I can also ask them through inline command. So I'm asking user to provide a function, and I'm asking them to use an inline command to provide a function. I hope you guys know what is inline command. If not, let's look at it. Inline. So similar to other options to define any function. So previously we saw we use f is equal to @x, and then we provide the expression of that. So similarly, we can also use the inline command. Under the parenthesis of that, we have to write our equation, okay, in the single quotation. So that will be considered as a equation or a function. Okay. So this is how inline command works. So I will ask user to provide a function through inline command for which solution is needed. Then I will ask them for a lower boundary, which I will consider as a input. Provide a lower bound for the search. Okay. B is equal to input. Provide a upper bound for the search. You can suppress the output. Okay. Now I will also need a one criteria for which I should stop the my program, right? Once that tolerance criteria has been reached. So here we discuss when to stop. Once we reach the desired tolerance. So this tolerance, you can put your in between value, or you can also ask the user to provide that. Okay. So here what I will do, we will also ask user to provide the tolerance data. So I'm defining tolerance. Provide a tolerance value to stop the iteration. Okay. So we have asked this basic information from a user. Now what I need to do, I have function A, I have two intervals A and B. So for bisection method, first step was to check whether this interval A and B, whether root exists between this interval A or B not, right? So let's say if user provides value of 1 and 0.5, let's say 0 and 1. Okay, so in case of 0 my value is -1, in case of 1 in case of 0 my value is -10, in case of 1 also my value is -10. So that means root doesn't exist in between these 2 points, right? Because both values are on the negative side. So in that case there is no solution. So first I will make a check whether the solution is between A or B or not. So for that, what we will do, we will put a if condition, and if condition will check. So I will find the function at A, I will find the function value at B, and check if this is less than 0. Okay. When this will become less than 0, when both signs are opposite, else it will be greater than 0, right? If it's less than 0, that means both signs are opposite. That means my root will lie in between these two values. Okay. So in that case, I do f print that and say the root of function is between %f and %f. I write a and b. Okay, so it will type that root of the function exists between a and b. Else, what I will ask user, that I will print that the given interval does not contain any root. Okay, and in that case we will ask user to provide another interval. I can end this loop here /n. Right, so let's save this as bisection method. Right, now first let's try to run this small part only, and then we will see how to do further calculation. So provide a function value through inline command. So inline, my function is, it's x to the power 4 minus x minus 10. Okay, provide the lower bound. So let's say first I am providing the bound 0, upper bound as 1 and tolerance as 0.401. It has between 0 and 1. Is there a solution? It should not happen, right? Just a minute. It should show an error if f of a and f of b. Yeah, it gave output here since it's a live script. So the given interval does not contain any root, please provide another interval. Okay, so since we know that between 0 and 1 we don't have any input. Now same thing, let's try, but this time let's try providing the correct interval 1 and 2. We know that root exists between 1 and 2. Okay, so in that case my output should be that root of function is between 1 and 2. Okay, so this is correct. So first step is correct. My step 1 of identifying the interval is correct. Now we will go to the step 2, which is to do the iteration. Okay, and we will do this iteration till certain tolerance is reached. Okay, so here I will consider tolerance as this absolute value of fx when it's less than the tolerance part. Okay, so what I will do, when we know that we are in the correct interval, we want to do some calculation. So I will use a while loop. While loop is used. While loop, what will while loop do? How long while loop will run? Can you recall from the previous class? What does while loop do? How many students? We have 4, right? Can any of you answer? What does while loop do when I use a while loop? So it runs a loop till a certain condition is satisfied. Once that condition fails, it will stop the loop, right? Correct? Yes, no? Don't worry or feel shy. You can answer. It's a communication, right? So it's a problem solving and doubt solving session. So you can communicate easily. Even if you are wrong, don't worry about it. So here, what I will do, I will run a while loop. We want, once the desired tolerance is reached, my iteration should stop. So what I will do, I will find the absolute value of given function. I'm right now not putting what value. If it's greater than tolerance, so this is my condition, right? Till this condition is satisfied, my while loop will run. Okay, what value to put, I am coming to that, right? So now we know that our solution lies between interval a and b, so I can find the in between value. I am calling it as x0. It will be a plus b by 2, right? So half of the interval. Now let me check whether the f of x0 is greater or greater than tolerance, right? If absolute of this value is greater than the tolerance, that means I have not reached my fx is equal to 0 part, right? So if I haven't reached that part, that means I have to do further iteration. Okay, so for that, now I have to check which interval to cross, right? So in the previous part, what we did that, let's say I found the value here and I find that this is also negative value, so that means my next interval becomes between a1 and b2, right? Similarly, further value, find that I'm finding the value here a3, which comes positive. That means my next interval becomes a3 and b2. So I have to check what will be my next interval, right? So for that, I can again use the if condition. If f of a into f of x0 is less than 0, that means my solution will lie between a and b, right? So in that case, my new interval becomes a is a, b becomes x0, right? And I can end the loop, or here instead I can do, let's do else if f of x0 into f of b is less than 0. If this condition satisfies, that means my solution lies between x0 and b. Okay, so b is equal to b. You don't have to specify b is equal to b, but still I'm just writing for sake of understanding. So this will help me to identify next interval. Okay, this will help me to identify next interval between once I have the new value of x0, right? Now once I know, I can further find new x0 as a plus b by 2, right? Now, so this is how this loop works. First is the condition whether our interval is correct or not. If our given interval by user is correct, then we check the value, we find the in between point, and whether we check whether if it's greater than tolerance or not. If not, then we have to identify what will be our next interval, if it is between a and x0, or if it is between x0 and b. Okay, I determine that, I update the interval value a and b, I update the interval xt, and based on that I compute the next value of x0. Now with this x0 value, again this function will be evaluated. If it's greater than tolerance, again same thing will be repeated. If this condition dissatisfied, then I will stop the criteria, right? So this is how basic loop works like. So let's try and see, and at the end of this we will display the solution to given function is display x0, right? So I run this, provide the value of function inline, lower bound 1, upper bound 10, 0.001. So it's doing some iteration and it has given me the value. Solution as 1.8556, right? And in our hand calculation that we did, it's 1.8555, right? So closer to that. So you are seeing I am getting this value. I can check my function value at 1.8556. So f at 1.8556 is this, right? So it's less than what tolerance I have provided. My tolerance was 1 into 10 to the power minus 4. It's less than that. And I stop the iteration. Okay. If you want, you can further modify this to better represent your data. So that will be, I can check in between intervals that what is the value of function and how it is changing. So you can do f printf. What I can do is, I want to create a table which provides the interval value. So I do f printf, right, iteration, then slash tab, value of a, so let's provide it by %f, slash tab, %f, b value, slash tab, %f x value, slash tab. Just give me a minute. Yeah. Iteration I, a, b, no, just here. F of x, b, a, let me define one variable I which starts at 0, starts at 1. Okay. Now what I will do, we will print the value of this I %d. So these are the basic f printf command. We have gone through this, right? %d will print integer value, %f will print the fractional value and stuff. So what I am doing, I am providing the iteration number, what is the corresponding value of interval a, b, upper limit, lower limit, what is corresponding value of x0, and what is the function value at x0. Okay, you can do that, /n to start a new line. Okay. Same thing here. Now let's run it and see how it looks. Inline. Okay, let's me provide 10 to the power 6 as a tolerance. There is some error. Iteration 1, unrecognized. Here. This line, because x0 is defined after this line, so it will come here. 1, 2. Okay. So this is how your solution will look like. Okay. I can get the table also. Yeah. So we haven't updated the iteration. I will do that. So at first iteration, my lower bound is 1, upper bound is 2, a by b value is this, and corresponding fx value is this. For second iteration, my a becomes 1.5, b becomes 2, in between value is this, and corresponding function value. And similarly, it will show you how your intervals are being updated with each iteration, right? Now here, I forgot to update this value, I is equal to I plus 1. If I do this and run it, line 1, 2. So you will be able to properly see how with each iteration things are changing, right? So our solution is coming as 1.8556. Okay. Now I can use F0 command, right? F0 command, provide my function, and initial guess, let's say initial guess I provide it as 2, and I'm getting the same solution, right? So through our code, our solution was 1.8556 with the help of fsolve command also, where my function f is already defined, right? So this is my function f, and I'm providing the initial guess value of 2, and I'm getting the same answer, right? Let's try 0 and see. So here, see, when I provided the value of 0, it showed me a different answer. Like whether this answer is possible or not, let's check. Minus 1.6975. So this also falls under our this also is closer to the 0 value. So it has given me the minus 1.6975 as the answer, because my initial guess was different. Similarly, in the bisection method, if your interval is different, then also you can find the solution, right? So let's look at how my function looks in between this x to the power 4 minus x minus 10. Between, let's say, minus 10 to 10, I am looking the function. So this is how my function looks. So actually you can see there are 2 points where it will cross the, it will cut the 0 values, right? So one is on the positive side, another is on the negative side. Okay. So you can see what we did here was we used our own bisection method to compute the answer. And same way what we found that with the help of inbuilt f solver also I am reaching to the same conclusion. That means if I want to solve any such equations, any such nonlinear equation through fsolve command, I can rely on such method, because I know I have verified that okay, the solution through the numerical calculations through bisection method is matching with the fsolve method, right? So all the command that we are using, fsolve or fsolver, f0s, right? So this all command has this basic numerical methods pre-built inside them, and when we call them, they execute this numerical method to find the solution, right? So next in the part we have Newton-Raphson method. So what we will do, we will discuss the Newton-Raphson method. Then I have some 2 problems which are kind of similar to what sir has taught, and then some quiz question. Okay. So next method is a Newton-Raphson method. So Newton-Raphson method, or just Newton method, is also commonly used method to find a root of an equation, and it relies on the differential value of a function, right? So you have to start with some initial guess, okay, and it iteratively determines the next value through this formula. So next iteration, x new is equal to x old minus function value at x old divided by differentiation of the function at x equal to old value, and you move along the differentiation along this slope of this function, and then you move closer to the your zero value. So thus it's a faster conversion compared to your bisection method, or let's say golden section method, where you halve the interval and it takes you for you to reach the solution, right? It takes you time, but compared to that you reach a quadratic solution in the Newton-Raphson method. So same example, but here we will find the solution. So for that, first we will need some initial guess. In the bisection method we needed an interval, but here we will need some initial guess for which we know the function value might be closer to x is equal to 0, okay, not necessarily exactly 0. So previously for f x equal to 1 we find the value is minus 10, x is equal to 2, value is 4. So 2 is closer to 0. For x equal to 2 my function is closer to 0, so I will consider this as an initial point. Then we have to find the next point through the iteration, and for that just give me a minute. Yeah, so we will use this formula. We will find the function value at x equal to 0, find its derivative at x equal to 0, and you get the next point. So you move further, then you do second iteration, you do third iteration, and you can see within the third iteration itself I have reached my solution. In bisection method I needed an 8 iteration, while here within the 3 iteration I am reaching at the value, since it's a faster conversion method, right? Now here again stopping criteria can be determined based on the function value. You can also use the f(x) value, differentiation of the function. You can also use the difference of function with its previous value, okay, to stop the criteria. Now again we will do the programming for the Newton-Raphson method to find the solution of such functions, such equations, and then compare it with the solvers that we already have, right? So let me create one more live script. Starting by clearing all the variables. Similar to bisection method, I will ask user to provide some input, right? So I'm copy pasting the same thing here. Okay, ask the user to provide a function value. Then what I will do, I will also ask the user to provide initial guess. Okay, provide a, we don't need two intervals, rather I just need a one value x0. So input, provide a initial guess for a search. Initial guess value for the search, right? And then we will ask for the tolerance, right? So first thing, now we have this value. Right now we don't have to, unlike the bisection method, we don't have to search whether we are in the region or not. We can directly begin our search through the while loop. So first what I will do, we will do while absolute value of a function of x at x equal to 0. If it's greater than tolerance, then my while loop should run. Okay, I'm ending it while loop here. Okay. So if the absolute value of function is greater than tolerance, that means we have not reached the minimum, fx is equal to 0 point. In that case, I will find the new value, x new is equal to x0 minus function value at x0, right, divided by, now I need differentiation of the function. I am writing differentiation of the function at x is equal to 0. right now I don't have this value. Okay, I don't know the what is the differentiation of the function. So for that case, what we will do, we will use again inbuilt MATLAB program to find the function value, find the differentiation. So let's say here, so there is this diff command which finds the differentiation of a function. So if you will search help diff, so what it does, it finds difference between vector and also approximate derivative. So it has a two use. One is to find the difference between the element of vector, and another is to create an approximate derivative, right? So for that, let's say my function f is defined as x to the power 3 minus 4 times x to the power 2. Okay, so this is my function. Now if I do diff f, yeah, it's not giving me any answer, right? Because this differentiation command works when you have a function in terms of the symbols. So if you define the function in terms of the symbol, so if I write sm symbol as x and write my equation is equal to x cube minus 4 times x square, and when I do diff eqn, so it's giving me the differentiation of the function, right? So x cube differentiation will be 3x square minus 4x square differentiation will be minus 8 times x. Okay, so now since these are different commands altogether, so some command has a specific requirement that you have to follow. So for differentiation command, okay, your argument or your function should be defined in terms of the symbols, right? So here you can see f previously was defined in terms of the function, but when I define it in terms of the symbols, this differentiation command is useful. Now in our code we have asked here we have asked user to provide a function through an inline command. So let me check whether inline command will work here or not. So let's say I do func through inline, okay, as inline x to the power 3 minus 4 times x to the power 2. Okay, so this is the function, and if I do differentiation of func, it doesn't work. So that means I have to use the symbolic representation. So for that you write here, so you have to define symbol x, okay, and you have to ask provide a function through symbols, right? So they have to directly write function as a equation here, like the way we have written here, equation is equal to this, through sims only, for which solution is needed. So this will be comment to our user. We will ask them to provide an input, we will ask them to provide a tolerance. Now I need a differentiation of the function, right? So I will define differentiation of the function as diff of f, right, which I am using to compute derivative at s equal to 0. This will be my x mu. Okay, once I know what is my x mu, I can take a printout of that also. So what I will do, like the previous part here, let me take this thing. Newton Raphson. Iteration x old, x new, and then my function value only. I need this part. Okay. Here I can print this value by %b. This will be my iteration /t. X naught is old value, so that will be %f/t, %f new value /t, %f, and /n. I need I, x naught is old, x new, then f at x new. So this will be my printing part. I will put it here once we find the x new value. Okay, so I'm putting the iteration, what is the previous x0 value, what is new x new value, and what is the function value here. Then you can update the xo as x new. Okay. I is equal to I plus 1. So this is our loop and I think it should work. Let's try. So I have to provide the function value first. Okay, so x to the power 4 minus x, it was minus 10, right? Minus 10. Initial value I provide as 1, tolerance is 0.001, and it's running the word. Okay. Oh, it gave an error. Conversion of conversion to logic from symbols is not possible. Just a minute, what change? Oh yeah, yes, yeah. Another thing, sorry, I forgot to mention. So when we are using the symbols to define my function, so here my function is defined in forms of the symbol. So if I use substitute any value, it won't consider it. For that I have to use subs command, which what it does is it substitutes the value in a given function, right? So it's a symbolic substitution. So you have to write subs my function value and then 2. So it will give me the function value at 2. If I write this, it will give me this function value at 1. So here I had made a mistake that I have wrote f of x0, but rather I should write substitute x0 in f. Similarly here also substitute subs, again subs x0. Okay. Now I think it should subs fx new. I think it should work now. Yeah, let's see. So here is your iteration, right? Your iteration, your old value, your new value of x, and then what is corresponding fx, right? So as you can see, this is how it's converging. Now initially the initial guess was 1, which was slightly away from the minima, right? That's why it took 8 iteration. Now let's say if I run the same code with a guess value closer to the minima, so instead of 1 I provide 2 value and do the same iteration. So it will converge in, I think, 3 steps. See, within 3 steps it has converged. So for such methods, your initial value also becomes an important aspect. Now same thing, we have already checked with the f0 command, fsolve command also. So you will get the same answer. So it will match, it is matching with what inbuilt solvers we have in Matlab, right? So this was regarding the Newton-Raphson method. So all the inbuilt softwares, all the inbuilt commands that you have for solving these numerical equations, be it be the numerical solution or be it be symbolic solution, it relies on the some sort of a fundamental methods which is running behind. You don't understand, you don't directly see it, but when you compare, when you understand these basic methods, you start to realize that okay, this method is actually working behind my function. When I'm using f0 command or when I'm calling roots command, what exactly happening is Matlab is executing such own code. So they have their own code which are more efficient and much works much faster than our code, right? And then it gives you the results. So this is how this command works. My idea here was to get you guys to get you guys more familiar with what are these inbuilt commands that we can use it, because following the same problem that sir has done will not give you much better insight. I think it's sir has explained it very well, so that's why I wanted to take a different route now. So I hope I did a better justification. Is this method clear to you, what we did in the bisection method or Newton-Raphson method, and how to utilize your inbuilt code to find the solution? If yes, then I will move forward with the next part. If you have any doubt, you can ask me right now. Is it clear? Yes, no? Okay. You can also type in chat box, okay, if you are not very open to talk. I assume then it's fine. So let's move forward with the next part. So these are two very small problems, and then after we have a quiz, and I think we have 15 minutes. It should work, yeah. So so you have been given a scenario where you have flow of fluid through a multiple section of pipes, right? So a piping system contains 3 different pipe sections which are connected in series. They all transport the water at 20 degrees centigrade with a given density and viscosity. System is laid horizontally, flow is steady and incompressible, and the pipe details are given. So water is flowing through 3 pipes which are connected in series with a length, diameter, roughness factor. Flow rate is common, so since it's a series, flow in a series of pipes, same flow is there, right? We have to calculate the total head loss in meter across this entire piping system using Darcy-Weisbach equation and the Moody chart or Colebrook equation to find the friction factor. Assume the flow is turbulent and use the Matlab to solve the implicit equations, right? Okay, so this part has been given. So right now we have 3 pipes. So what we will do, for each pipe we will compute what is the corresponding friction factor and what is the head loss, and summation of all these 3 head loss in all 3 pipeline will give you the total head loss, right? So let's look at this example. And I had friction in pipe, not this one, yeah, this one. Okay, so I will take some data from here. So this is the given data. We have been provided with the density value, viscosity value is given. Now flow rate is given in the liter per second. So we are converting it back to the SI unit, which is meter cube per second. So it's basically dividing it by 1000. Your gravitational constant is 9.81. So this is the basic information. Now we have piping system information. So I will create a matrix which will contain length, diameter as well as roughness in all three cases, right? So my row, I will create kind of same matrix where row will correspond to pipe 1, pipe 2 and pipe 3. First column will correspond to length, second will correspond to diameter, and third to the roughness. Okay, so pipe, for the first pipe I have 100 meter length, 150 mm dia. So 100 meter length, 150 mm dia, so I can convert it back to 1000. I am converting it into meter, and then roughness is 0.1 mm, so 0.1 by 1000. Okay, so this is my first information. Now for the second pipe, 75 meter length, diameter is 100 mm, so 100 by 1000. Roughness is 0.2, so 0.2 by 1000. Third pipe, length is 50, diameter is 200 by 1000, and roughness is 0.05. Okay, so this data is ready. So it's a piping data where row corresponds to pipe, my first column is length, second column is diameter, third column is our roughness, right? Roughness. Okay, so I have defined all three. Now what we have to do, for each pipe we have to calculate the head loss. Okay, so I will do a for loop. This for loop will run from pipe number 1 to pipe number 3. Okay, now here I can add do 113, or let's say I don't know the size, how many pipe I have. So in that case I can use pipe size 1, right? So if you recall, this will give me the number of rows, right? So if I do size pipe comma 1, it will give me the row. If I do pipe comma 2, it will give me the column. Since it's a 3x3 matrix, everything is same. But let's say if I have 4 pipes, then I don't have to worry about changing this number, right? So this will be my for loop under which all the calculation will happen. I want to find a total head loss, right? So I am declaring this variable total head loss, whose initial value is 0. This value we will update over time, right? So for the first pipe, now I know I'm coming, so this row will correspond to first pipe. I loop will correspond to the pipe 1. I will extract out the data of pipe, which is first row, first column. This will be length, diameter is second column is a diameter, and roughness, so let's say I'm calling it E, is pipe, corresponding row and third column, right? So this is my data. Now once I have this, okay, once I have this, what I will do, I will compute first Reynolds number. Reynolds number is equal to your row into your velocity. So we have to find velocity first, then your diameter by your mu, okay. So into velocity, vel, which I will find right now. So I need to find velocity. I don't have a velocity as of now. So to find the velocity, we have the flow rate. To find the velocity, it will be flow rate per unit area, right? So I need to find the area. Area is equal to pi d square. So d square by 4. So this is your area, right? Pi d square by 4. Velocity is equal to q by area, correct? So this will become your area, and this is your Reynolds number. Now if you will recall sir's lecture, what we do generally, once we find the Reynolds number, right? Once you find the Reynolds number, you have to find the corresponding friction factor, right? Here we have been said that we have to assume we are in the turbulent region. We can check based on the Reynolds number also. Let's say so once we are in the turbulent region, we have to use Darcy-Weisbach equation to find the head loss, which is F into LD by V square into by 2G, right? Where friction factor we find from solving the Colebrook equation, okay? So for that, I will just directly use this function, since it's already there. So once we know the Reynolds number, you can also print the Reynolds number, right? As printf, or rather display, to check whether we are in the turbulent region or not. I do this now. Okay. So this equation is defined in terms of x, okay, 1 upon under root f plus 2 times log to the power 10 epsilon by d. So epsilon is nothing but our E, so I will change that notation. D is already defined, E by D. Reynolds number we have calculated, and SQ, which we have to solve, and I am using F0 command. So F0 command is used for single variable non-linear equation. So you can provide the initial guess, you can provide the in-between interval where you want to solve it. It will give you that value. Then you have to use Darcy-Weisbach equation, which calculates the head loss, right? So this is that equation. So what we are doing here is, I am using Darcy-Weisbach equation to find the head loss, which is F times L by D V square divided by 2G. This is writing it in a different way. This will calculate the HF. I will add total head loss. So here my T is capital, total head loss, to this new value. And this is how my for loop will work. And at the end, I can write printf total head loss in a system is this total head loss. right? Let's try and run this command, see what happens. Unrecognized. Oh, sorry. Here I have to use well. So it has computed, see, all the Reynolds numbers are 10 to the power 5. So we are well in the turbulent region. So this Darcy-Weisbach equation holds. We can use this equation and corresponding equation for F. And this is the total head loss for my system, which is coming as 10.766. Okay, this much meter, its unit is meter, so we have to write that also. Head loss of a system in meter is this, right? And this is how it will look like. So same problem what sir has taught, but I am just using for a different example. Let's say if you have flow through a different size of pipe, what will be the scenario? Then there is the second problem, which is whether to check whether our flow is laminar or turbulent. Do you have any doubt in this question? I think this is very straightforward, just a slight tweak to the what actual problems sir had taught. Is it clear, or does anyone have any doubt? I don't see anything. Okay. I assume it's fine. Okay. So let's move forward with the second question. So here you have been asked to compare a head loss for a laminar and a turbulent flow in a smooth pipe. So your data given is pipe diameter is given, water density is given, and viscosities are given. And we have to compare what will be the head loss in this two scenario. So now the data is diameter is 50 mm, so D is equal to 50 by 1000. I am converting back into meter. Your density is 998 kg per meter cube. Okay, I don't have to write the unit. You can comment what are the units. This is in meter. Okay. Then you have been given two velocity. One is 0.1 and second one is 3. So I will create a velocity vector well which contains this two value 0.1 comma 3, and its unit is meter per second, right? So this basic data I have. Now I have this much data. I have to first find the Reynolds number for, like, here it's directly mentioned that this is laminar and this is turbulent. Okay, so first I have to check what is the Reynolds number for velocity v1, what is the Reynolds number for velocity v2. That can be done by rho vd by mu. Okay, viscosity is not given here, so for that I think we can use the previous example. What will be the viscosity? Yeah. Okay, I think I forgot to mention some of the data here. Length, pipe length will be needed, and viscosity. Yeah. Okay, no problem. So this is your viscosity. Okay, this is Pascal into second. So what I will do, I will run again a loop for I is equal to 1 gen 1 length of well, right? So I have two velocities right now. So what it will do, it will run through both all whatever velocity you have. This loop will end. In between, what I have to do, I have to first calculate the Reynolds number, that is your density rho into velocity, so vel I into mu by d, okay, rho vd by mu. So this is your Reynolds number. You can display the Reynolds number, this Re, okay, Reynolds number is displayed. Now I have to check if my Reynolds number is less than 2100, that means I am in a laminar region. Else if Reynolds number is greater than 4000, that means I am in a turbulent region, right? So correspondingly I have to use a different equation. If I am in a laminar region and this is I am in a turbulent region, okay, so I have to use corresponding equation. So for the turbulent region, we previously checked, right? So we have Darcy's Darcy-Weisbach equation, right? I can use that. So first I am finding the friction factor value. For that I will need Reynolds number and some initial gas. Now here we don't need a roughness part because I have considered a smooth pipe. It is given that flow is under a smooth pipe, so E by D ratio will be 0, so you don't have to provide it. You are using fsolve command, f0 command, to find the f value that you will put to find the head friction head loss here, right? If you are in the laminar region, then we will use Hagen-Poiseuille equation to find the friction head loss, right? So this is that equation. Again, I think I will need a length value which is 100. L is equal to 100. This much meter. MUL. Here it will become vel I. Dense. G value I will need. So G 9.81. Okay, I think all the data is correct. Here L by D. This will become well. Okay. So once this is done, now only thing is I have to display this value. So for that I can use, once this loop is completed, if an if statement is complete, I'm using fprintf command. I'm just copying pasting it from the other script because I think it's already 8 o'clock, right? So I'm just printing it, the corresponding value, and it should give me the answer, right? So let's run it. So you can see this is how it will look like. My flow is in laminar region for the velocity 1. I am getting this Reynolds number. So Reynolds number is very less, you can see. So I am in a laminar region, right? So first is like 1.996, so I'm which is close to 2, and 59.88. So then you can change the value and check what else you can do here. So let's say I provide the velocity value of 1000 and see what is happening. Then I transfer it to turbulent region and find the HF corresponding to that. Okay, it's very high because 1000 velocity, you can consider 1000 meter per second is too much high velocity, right? So let's say maybe not 1000, let's say 100 also. I'm still in laminar region, so 5. So this way you can find the what region you are in, what is the corresponding friction loss you will have corresponding to that region. Okay, so this was the two problems. Now I do have a quiz based on the what questions we have, but considering the time, I will stop here today. Maybe at the start of next lecture we can try this quiz. else you can try it on your own. If it works, like if you are able to easily answer them, I think it should be easy to do, then fine. Else you ask me on the start of next lecture first. We will discuss this question and then move forward, right? So these are very normal question actually. These are based on the this inbuilt solver commands that we have used and how to use them, and some small Matlab snippets for you to try out. Okay, so that's it for today. Thank you for joining. If you guys have any doubt, let me know, else I will stop the recording and end the class. Is the way I'm approaching to this course is fine, or if you want to give me any feedback, that is also good. Okay, I think then we can stop here.